Hello, continuing on with now vector addition. The secret with vector addition is that you have to add only in like directions. So if you have something that, first of all, you have to also, with vectors, you have to do both a direction and an amount. So you could say that this is, let's say, 20 pounds of force at a 30-degree angle from horizontal. So the idea here is that you have to break this down into a horizontal component and a vertical component. Now also with breaking it down, that if you have multiple components, you can now figure out how much when you add them up. But to start with, we're just going to deal with one force, one direction, and trying to break it up here. Now, the question is, how do we break things up? Well, if we call this angle right there, we have an angle theta, and then we have to pull our definitions here. So we have sine of the angle is the opposite over the hypotenuse. Now this only works with right angles, but luckily this horizontal and vertical, they're called orthogonal because they are in two separate directions. Now the cosine is the adjacent over the hypotenuse. Now here, if that's our angle, our adjacent would be next to it. Our opposite, of course, would be opposite our angle, and the hypotenuse is the length here. So to take this and break it down, we have to put in what we know and solve for what we want to know. So notice our angle here is 30 degrees. So we're going to have the sine of that 30-degree angle is our opposite, which we don't know, that's our vertical component here, over our hypotenuse or our length, which in this case is 20. Our cosine is our adjacent or our next to divided by our overall length. Now, this is when you bring in a calculator, because the one thing you do need to know is sines and cosines. Now, I have a calculator here, and it is in degree. That's an important thing. So if we do 30 and then sine, it's 0.5 or 1/2. Now, certain sines and cosines you'll actually get to know opposite over 20. And now if we want to do the cosine, clear, 30 cosine is 0.866. Now, depending also on how everyone does it, that's also known as square root of 3 over 2. But I'm going to keep it a decimal right now. So we have our opposite divided by 20 is 0.5, and our adjacent over 20 is that. Now, if we want to get our variable here by itself, we have to do the opposite to get rid of what's on the same side. Notice that we have our variable, our opposite, divided by 20. Well, we have to do the opposite division, which is multiplication. So we need to multiply both sides by 20. Now, 20 divided by 20, anything divided by itself goes away. So it goes our opposite here. And 20 times a half, in this case, is 10. So if you think about our triangle there, that is actually 10. Now we have this one. So again, we're dividing by 20. Need to multiply by 20. Now, we have our that times 20. So it gives us with 17.32 is our adjacent. So now you may also see this as your R or resultant vector, that's your overall. And this is your R in the Y direction, and this is your R in the X direction. So that's all those little subscripts mean, are saying what's happening in the horizontal direction and what's happening in the vertical direction. So that tells us how to go from, remember we started with a solid line and a direction, and we kind of broke it down. Now you're saying, well, what happens if they say it's down here? Well, if it's down here, they'll tell you something like this is, there we go. The angle always starts from your horizontal. your horizontal x-axis here, your positive x-axis. So an angle over here, because you go 90, 180, so they may say this is like 235 degrees. Well, notice that that's from here going all the way. When we make our little triangle breakdown here, we only care about the little angle, that little bit. So it's 235, but you notice that from here to the horizontal is 180. So if we do 235 minus 180, 5, this is only 55 degrees. So when you break it down, you're going to be taking the sine and cosine of 55 degrees, but also because you sketched it out, you know that your y component here will be negative, but your y component will be negative, and your x component will be negative because you're down here. You're going to the left and you're going down. It does help. Now, after a while of doing this, you can go, oh, obviously that angle is between 180 and 270 degrees, so it's in the third quadrant. Remember, we count 1, 2, 3, 4 quadrants. So obviously it's negative. Well, it obviously means you've done it so many times that you get used to it. So this is how you kind of start in the one direction. Now, there are times when we have to go in the opposite direction. So for the opposite direction, let's say they already tell us that our resultant in the x direction is -5, and our resultant in the y direction is 10. So if we want to draw that, well, we always draw our xy axis here, and we said x is -5, so it's over here to the left, and y is +10. So we're up here, so we're going -5 and then up 10. So we want to know what this overall r is. Well, notice here, because we went over and up, we have a right angle. And if you want to know the hypotenuse, or the long side, the side opposite the 90-degree angle, we find our then Pythagorean. Very interesting character. If you ever actually look into the history of Pythagorean, kind of a mystical, kind of woo-woo a lot about, even though really strong mathematician, just had a lot of really unusual thoughts and behaviors. But in this case, we know his math works. So we run with it. So it's this is actually, if you remember the Wizard of Oz, this is after the Scarecrow got brain. This is what he said: the square, the hypotenuse of a right triangle is equal to the sum of the squares of the two component legs. What does that mean? Well, it means if you square that and you square that, you add them together, that equals the length of that squared. And there are tons of ways to prove this. You actually don't need algebra to prove it, but geometrically it makes it a little bit hard. Luckily, we have algebra. So, we know r squared is equal to -5 squared plus 10 squared. R squared is equal to 25. Remember, -5 times -5. Negative times a negative is a positive. 5 times 5 is 25. 10 times 10 is 100. Or r squared is equal to 125. Now gives us r squared. We want to know what r is, so we have to do the opposite of squaring. The opposite of squaring is the square root. Now again, if you can get an exact square root here, do that. If you can't, we're going to bust out the calculator. So we got 125, square root button. It's 11.18. Now it also depends on what you're going to put down in terms of how exact you were to start off with. If you weren't as exact, then you're going to get something else. So that gives you the overall length that you're dealing with. Now the other thing you have to worry about is the direction or the angle of what you have there. Now, so we have to now figure out, so we have our resultant distance. Now, some problems that will be enough. It'll say, what is the resultant size? Well, we know the size, but if you're talking vectors, vectors are size plus direction. So we have to figure out, remember, all angles are given from the horizontal here. We have to figure out this angle. Well, notice that with this triangle, we're just going to find out what that angle is there. This is why it also helps to draw it, because once you draw it, you kind of know where to go from and where to go to. Well, this is an inexact number, right? 11.18 with a whole bunch of other stuff. We don't like inexact. So we're going to use the opposite and adjacent. Well, tangent is opposite over adjacent. So if we find out the tangent of an angle is opposite, which is 10 over adjacent. Now here we don't care about signs because we're only figuring out what this is. Or tangent of an angle is 2. Now, we have to get the angle by itself. Well, notice that we have a tangent here, so we need to take the inverse tangent of both sides to undo it. Now you also see it written as the arc tangent. So, again, make sure your calculator is in degree, not radian. So if I put 2, a lot of times your calculator is going to have to hit the second button here. You know, notice this turns into inverse tangent. So we hit inverse tangent. It's 63.4 degrees. Well, that's great, but that's this angle here. That's 63.4, but we want to know most of the time what is it from that. Not necessarily from that way you get always consistent degree. Well, remember we also said this flat line here, the total thing here is 180. So if we know that whole thing's 180, this little wedge there is 63.4, then all we have to do is do the subtraction, and we can get our answers. 10, carry the 1, carry the 1, 18, carry the 1. So what we have here is 116.6 degrees. Now, it also depends on what you're looking for. You know, a lot of times if you only need the angle those two make, it'll be that. But if you need to know the angle from your horizontal axis, you'll need to know this. A lot of it depends on the actual problem you're looking at. But notice that what we did is we did one problem where we started with the resultant, broke it down, and then we started with our components, and we figured out our overall length and overall direction. So these two are kind of, if you notice, it's going one way, coming back the other. If you have any questions, post them in the comments or below, or give me a contact. Thanks so much for watching.